Welcome to 9-4 Arithmetic Series, and we have been dealing with sequences, both arithmetic and geometric up until now, and this will be the first time that we've really talked about a series in algebra. And a series is an indicated sum of terms, indicated sum of the terms of a sequence. And we have a finite and a infinite series, and a finite has a first and last term, a starting and a stopping point. And a infinite series has it goes on without end. And, infinity, infinite. And what we're looking at here is we talk about the series, and it is going to be the sum. We will learn we will go into the summation notation, which we will be working with this symbol sigma, which stands for summation. So as we look into finding the sum of a finite arithmetic series, you are going to need to examine this formula. And it is telling me that the series of sum in value is going to be equal to the n divided by 2 times the first and the nth term, which would in this case be the last term. So as we look at this, looking at our example, it says, what is the sum of the finite arithmetic series? And we are given 4, 9, 14, 19, 24, until it goes on until our last term is 99. In order to find out some of the stuff that we need, well, we don't know what term number this is. So what we can do then is figure out, well, in order to calculate our common difference, we are able to take one number and subtract the previous number, and that gives us 5. And do it again. If we take 14 minus 9, gives us a 5, so we know our common difference is going to be 5. So now we can use that to figure out, well, what term number we have, and we could say that the number of terms is going to be 99. To find the number of terms, we take the first and the last term. The first term minus the last term is going to be 95, so we have 95 divided by 5 is going to be 19. Therefore, we have 19 terms plus the first term, which is going to be a total of 20 terms. Okay. There's probably another way we could check that too. If we were to go with an is going to be equal to the first term plus n minus 1 times 5. And we know that the term that we're looking for is going to be 99. And we have 4 plus n minus, let's just go ahead and do that distributive property. 5n minus 5. 98 is going to be equal to 5n. I think I have clearly done some math wrong. And I have. Let's see here. So if I go back, I don't get ahead of myself. And let me go ahead and do all the math instead of just doing it in my head. Here, this is going to cancel out to -1, or should I say -1, so I will add 1 to both sides, and I have 100 is going to be equal to 5n. Therefore, n is going to be equal to 20. So there we go. I just checked this thing right here. And sure enough, the 99 is going to be the 20th term of my series or my sequence. So I have the n value is going to be 20. Do some substitution. I have my A1 plus my A20, and I'm going to get the series of the first 20 numbers is going to be equal to 10 times 103, which is going to be equal to 1030. There we go. There is my finding the sum of that finite series. Now going on to this, using this in a word problem, the company pays a $10,000 bonus to a salesperson at the end of their first 50 weeks. If they make 10 sales in their first week and they improve their sale numbers by 2 each week thereafter. One salesperson qualified for the bonus was the minimum possible number of sales. How many sales did that salesperson make in week 50 in all 50 weeks? Okay, well, first of all, let's look at how do I figure out what did he make there in a 50 or week 50. I do know that they have given me, let's see, the first A1 was going to be 10. Then they told me that he made 2 more each week. So that would be 10 plus 2. So we got to 12, 12 plus 2, got to 14. So we know that we have A1, we have A2 and A3. But if we look at what we had before, let's see here. So here is my explicit formula. So I replace n with 50, substitute in A1, 10 for A1, then substituting in 50 for n, and go ahead and multiply this out. I have 2 times -1 is -2, 2 times 50, so that gives me 100 minus 2 is 98, 10 plus 98 is going to be 108, so A50 is going to be 108. That's my 50th week. Now if I turn around and do my additional substitution, we will come over here and n is again going to be 50. So I substitute in 50. I know what A1 is, and then A50 we already determined is 108. Therefore, we get the series of the first 50 terms is going to be 25 times 118, which is going to give me 2,950. And there were going to be 108 sales in week 50 with a total of 2,950 sales in all 50 weeks. And as we continue on here, we're going to talk about writing this series in summation notation. And again, here is my summation notation. So I'm going to we have this sigma, we will use the explicit formula right here, and we will have a upper limit, and we will have a lower limit. The lower limit is going to be our beginning, the upper limit is going to be our end. So as we come over here and we talk about summation notation, it says what is the summation notation for the series -5 plus 2 plus 9 plus 6, so on and so forth until we get to the last term of 268. I was able to find out the common difference is going to be 7. I took one term and I subtracted the previous term and it gave me 7. So 2 minus a -5 is 7. 9 minus 2 is 7. So therefore I know that my common difference is going to be 7. Substitute in my common difference. Substitute in my first term. And now I have figured out that AN is going to be equal to -12 plus 7n. So there is my explicit formula. I've done some substitution here. There's my explicit formula into my summation notation. And I know that, well, I don't know. What I need to do is figure out what term is this thing right here. So if I come over here, I use my number of terms, so I do some substitution. AN is going to be 286 because that's my last term. That's some future number. And then equals to -12 plus 7n. Add 12 to both sides. I get 280 is equal to 7n, and then divide by 7, and n is going to be 40. So this is going to be my upper limit. Okay. There we go. So my upper limit is going to be 40, upper limit, and summation of my explicit formula, and I am beginning at my first term of n equals 1. There you have it. Let's see, let's do this next term. I know, or this next example, and I know that I have the answers here, but that does not stop you from working them out on your own. So as we look at this example, I have 500 plus 490 plus 480, so forth and so on until I get down to 10. So we could turn around again and find out that my common difference is going to be negative 10. I could turn around and say 480 minus 490 is going to be negative 10. So there is my common difference. I start off with the explicit formula, starting off with A1, and I do some substitution, and then I have done my distributive property here, and I get 500 minus 10n equals 10. Again, combine like terms. My constants are like terms, so I have my formula is going to be 510 minus 10n. Here is my explicit formula. Let's see, maybe make it a little bit more clear, right? So we have 510 minus 10n. We know that my first term is going to be n1. My last term we determined was going to be 50. So then the summation notation is going to be the upper limit of 50, the lower limit of 1, and the explicit formula of 510 minus 10n. And if we were on a all-year schedule where we are working half the time, our classes are half the size, this is where we're going to take a break and do some work. If it's a block class, we are going to continue on here, and we are going to find the sum of a series. And what is the sum of each finite series? And we just recently talked about this notation where we know my upper limit is going to be 40, my lower limit is going to be 1, and my explicit formula is going to be 3n minus 8. All right, so in this example A, I'm able to figure out that it is linear. It's arithmetic sequence, right? My n is to the degree of 1, and I am subtracting 8 from each term. So if I look for in order to find the sum of each finite series, we had a formula. The sum of some series is equal to the last term divided by 2 times a1 plus the last term, an. So if I find my first term, a1 is going to be equal to negative 5, and then a40 is going to be equal to 112. And of course, in order to do that, I just plug in my upper limit and lower limit into my explicit formula, and I have done some inverse operations here. So S of 40 equals 40 divided by 2 times negative 5 plus 112, or 20 times 107, which is going to be equal to the summation of those 40 terms is going to be 2,140. Let's see here. This next example B, not arithmetic, but we can see that it is going to be the summation from the lower limit of 1 to the fourth term using the explicit formula n cubed. So as I take my first term, I have n is 1 cubed plus n is 2 cubed plus n is 3 cubed plus n is 4 cubed. And I go ahead and cube that. I get 1 plus 8 plus 27 plus 64 is going to be equal to 100. So the summation of that series is going to be 100. And next here we have a summation starting off with 0 and as a lower limit to 100 as an upper limit. And it is going to be negative 1 times, negative 1 to the n power. So when we fill that in again, this is going to be negative 1 to the n power. Figured I'd move it down here to where we can see it some. So what I've done here is I've done some pattern matching. So -1 to the 0 is going to be 1, because anything to the 0 power is 1. -1 to the 1 is going to be -1. -1 to the 2 is going to be +2. -1 to the 3 is going to be -3. And then -1 to the 4th is going to be a +1. Now, what I've just determined here is when I look at my first 5 terms, first 4 terms, I'm going to see a pattern forming. So 0 and 1, we have 1 minus 1 is 0. Then we have 2 and 3 is 1 minus 1 is 0. So as I can see, it will continue to repeat. And I could even turn around and say, well, -1 to the 5th is going to be -1. So we will start to see that pattern continue. So it'll repeat every 4 terms or 25 times, and then that's what you do to get to the 100th term. And so as we continue, we know that the sum of this is going to end up coming to 1.